And actually, before you even do that, even if they were alike, you would want to simplify them. And so you're going to look at each radical and say, can I simplify it? And if you can simplify it, get it in simplest terms first, and then see if at that time you can combine any of them. So I'm going to look at the first one, 32a cubed, and I am going to simplify the number first. And I'm just going to use my factor tree here to do that. All right. My index is 2, so it needs to group in pairs to come out. So these group, that comes out. These group, so that comes out. This does not group, so that is going to stay in. All right. Then I am going to look at my variables. All right. There are 3 A's. You can either write out the 3 A's, or you can say 3 divided by my index is going to be 1 with the remainder of 1, which tells me that 1A stays in and 1A comes out. This is simplified. I'm going to move on to the next one. And just for simple, because I see it happen, don't forget you have a plus sign there. All right, so bring your plus sign down. Then we are going to look at the next one. Now, when I look at the next one, I have a 2. That's all I have. It will not pair up with anything. So that 2 is going to stay on the inside. When I look at my variables, I actually have the same thing I had in the first one. I have 3 A's. 3 divided by 2 is 1 with the remainder of 1, which means I have 1A that comes out, 1A that stays in. Don't forget, you have a minus sign here. Now here I have a 3 on the outside, so that 3 is automatically going to go on the outside. And then I have a 6. Well, 6 just factors to 2 and 3. Nothing pairs up with a 6. So that 6 is actually as simple as it gets. So that 6 is going to stay in. All right. You do want to simplify your coefficients here. 2 times 2 times A is 4A. 2A on the inside. This is a 1A, don't forget, with a 2A on the inside. And we have minus the 3 squared is 6. I now have like radicals, right? Not only do I have like radicals, but my coefficients are also alike. And so those two things have to be true. These are alike, so I can add the radicals. And the things on the outside must be like terms to be able to add those. And so I have 4A's plus 1A gives me the 5A. My radical does not change. The 3 squared is 6 cannot combine with anything, which is where I get my final answer. A right angle is an angle whose measure is 90 degrees. Hopefully you already know that. So then a right triangle has only one right angle. The reason it has only one right angle is triangles only add up to 180 degrees. And you need 3 of them to be a triangle. And if you have 2 that are 90 degrees, you're already at your max. So the triangle can have at most one right angle, and it is considered a right triangle at that point. The key to the Pythagorean theorem is knowing how to label it. A theorem is a statement that has been proved always to be true. So a theorem has been proven. You'll have little things called postulates and definitions. Those are different than theorems. Theorems have gone through a process of being proved. Pythagorean theorem is one of them. The sum of the square of the lengths of the legs of a right triangle is equal to the square of the length of the hypotenuse. All right, so what's important here is that you know what the hypotenuse is. Because the a squared plus b squared is adding, and we learned way back at the beginning of Algebra I, which seems like forever ago now, that when you add, it doesn't matter what order you add it in. 2 plus 3 is 3 plus 2. What's important is that c. The c squared is the hypotenuse, and that is the one that has to be by itself across the equal sign. So the hypotenuse specifically is the one that is across from the right angle. So we have the right angle. The one that is across from it is your hypotenuse. It is also your longest side of your triangle. So even if they don't note which one's the right angle, you can tell by the length of the sides. This is always your longest side right here. So a squared plus b squared will always equal c squared. There's a ton of these proofs out there. They do it with areas of squares. There's just a ton of proofs. But this will always hold true for any right triangle. So if we are given something like this, the most important thing is to decide which one is my hypotenuse. If I'm looking at this, my hypotenuse is going to be which side? Yeah, my 15 is my hypotenuse. So they want me to solve for the length of side B. I'm going to say B squared plus 12 squared equals 15 squared. All right, and so And you know what square root of 81 is. What is the square root of 81? 9. So that means my side length is 9. You can check it. Does 9 squared plus 12 squared equal 15 squared? Yes, it does. And so the length of that side is 9. The length of that side is 9. A couple things I actually want to point out here. When you are solving for a square root, you technically have to consider the positive and negative root. So this is going to be important next chapter, actually, when we're doing some solving. The reason you have to consider the positive and negative root is because 9 squared equals 81, but so does negative 9 squared. Here's the thing. When you're doing it with right triangles, I am asking you for a length of a side. Can the length of a side be negative 9? No, it cannot. And so when you're doing a right triangle, typically you just assume we are doing the positive root because you are asking for a side length. Now, I say this because as you get into higher mathematics, you'll be doing it on like a coordinate plane. And then it will matter whether or not it is positive or negative. We're going to do a little bit on the coordinate plane, but again, we're just going to be asking for length. When you get to like trigonometry, when it comes to like unit circle type things, negative may be important. And in the next chapter, when we do square roots, we're going to have to do two answers, a positive answer and a negative answer. For this particular section, you can always assume it's positive because we're talking about length. However, you may not be handed a nice pretty square root of 81. So this next example is like, well, what happens when it doesn't have a perfect root? Well, we're going to go all the way back to section 1 from this chapter, and we are going to simplify our roots. And so you're not going to give me a decimal at this point. You're going to do your factor tree and just give me a simplified root if it doesn't have a perfect root. In this example, C is my hypotenuse, so that is what I'm solving for. I am going to say then 20 squared plus 10 squared equals C squared. So I have 200 plus 100 equals C squared. C squared equals 300. Now 300 does not have a perfect root. Wait, did I do that? No, I said 200. This is 400. I was about to say that should be 500. All right, so 500 does not have a perfect root. So I need to use my factor tree and do my perfect root. Now, I will say with this, I would likely not do 2s just because you're gonna do it forever. So you can do ones that you know, because 50 is gonna be an easy one to do. So you can do 2 if you want to. Just make sure that you pay attention to what you're doing here when you get way down in the process. So we have that right there, all right? Or you can do 50 and 10. Just make sure if you break it up like that, that you pay attention to all of them that are hidden in there. I want things that group up. So I want these 5s will come out. These 2s will come out. And then this 5 right here is all alone, so he's going to stay in. 10 squared of 5. This is how you would leave your answer. So the hypotenuse is 10 squared of 5. All right? Whereas before, we had a nice round square root. You may not. Simplify it as much as you can and then leave it in radical form. Your instructions will typically say exact value. This means exact value. If you ever see, especially on a standardized test, round to the nearest, they want you to put it into a calculator, right? But I want exact value for these. So just simplify your radical and leave it that way. All right, I want you to try a couple of these. They are using the same triangle here, and they want C. For this one, I want you to think about it. Could this be a right triangle? I want you to tell me if this could be a right triangle and how you could tell me that it could or could not be. 1. Yeah, it's 5. All right. A and B are 4 and 5. This one gave you a square root, which was not able to be simplified. Square root of 41. All right, square root of 41. What about number 13? If I were to look at this and try to see if this is a right triangle, the first thing I have to decide is if it is, which one of those would be my hypotenuse? Which one would be my hypotenuse automatically?
10.
Why?
Because it's the longest.
It's the longest side. So that means that 10 would have to be my C, and the other 2 would have to be my A and B. All right? So then you just have to say, does the Pythagorean theorem work for this? Well, let's look. A squared plus B squared should equal C squared if this is a right triangle. So we have 64 plus 36 equals 100. Is that true? Yes, 100 equals 100. This is a right triangle. That is a right triangle. Yep. Okay. And so if the Pythagorean holds true for the three numbers, then you can create a right triangle with those three lengths. If the Pythagorean does not hold true, you could not create a right triangle with them. It would not work. Think about why that is true. So if I have a right triangle specifically, all right, it's going to hold true to that Pythagorean theorem. But if, let's say, my hypotenuse is too long, it is going to stretch these out, right? It's going to push them. So if I were to lengthen this guy, it wouldn't meet the ends of those, would it? They're not without changing the angle. So I could meet the ends of them if I changed the angle, right? They could stay the same length, but my angle would no longer be 90 degrees. If I made it shorter, it wouldn't reach the end. I would have to scoot these side lengths in to be able to meet the sides. Also, it would no longer be a right triangle. So the only way it can be a right triangle is if it meets this theorem. All right. If it does not meet this theorem, you would say, no, it is not a right triangle. And the reason it does not is because it does not work with the Pythagorean theorem. This says use the Pythagorean theorem to find the distance between the points -3, 1, which is right here, and 5, 4, which is right here. Now, if I wanted to find the length between -3, 1 and 5, 1, I could just subtract my x's. Or if I wanted to find the length between 5, 1 and 5, 4, I could just subtract my y's. But when I go across here, all of a sudden I can't just add or subtract the units, right? Because I'm doing diagonally. However, you'll notice they drew a right triangle because they want that distance. And so I can use the distance between my base and the distance between my height and the Pythagorean theorem to figure out what the length would be. So let's say I want to figure out this distance down here. I am going to take 5 minus the -3, right? That's the only thing that changed. My x's changed when I'm going left to right. So I'm going to take my second x and I'm going to subtract my first x. And that will give me my base length. How long is my base then? 8. All right. If I wanted to find my height, I would just subtract my y's. Well, I would say 4 minus 1. So I would take my second y, I would subtract my first y, right? And what would I get there? 3, all right? Now, once I get those numbers, I actually have to square them, right? A squared plus b squared, right? I have to square them. So I would say 8 squared plus 3 squared. Yes? And that gives me c squared. I actually want c. What do I have to do at the end? I have to take the square root. So I'm going to say 64 plus 9. He's not going to have a perfect root, right? So square root of 73 is what I'm going to get. So basically what I'm doing is I'm adding the differences and I am going to take the square root of them. And that will give me the length that I am looking for. That will give me the length that I'm looking for. All right. This actually creates the distance formula. If you look at the next page, they've just written it down in x's and y's. We have our second point over here and our first point over here. If I want to find the distance between the 2 points, I'm going to take my x's and I'm going to subtract those. And then I'm going to take my y's and I'm going to subtract those. I'm just going to square them, add them up, and take the square root. That is my distance formula. It looks like this huge formula. All it is the Pythagorean theorem written out. Right? It's the Pythagorean theorem written out. You subtract your x's and square it. Subtract your y's and square it. And to get your final answer, you have to take the square root because you found c squared and you need just c. So this is a formula that you are going to need to memorize. I don't know if you covered it in pre-algebra, but you will use it in geometry and in Algebra 2. And going forward, you'll use this formula right here. So that's one that you really need to know. You definitely need to know it for the test. So square root of x2 minus x1 squared plus y2 minus y1 squared. So let's see how we use it Use the distance formula to find the distance between these two. All right? So my distance formula, I'm going to take the square root. And I'm going to say subtract my x's. 5 minus 2. That is my a. I need to square it. Subtract my y's. 1 minus 1. And I need to square it. What is 5 minus 2? 3 squared. What is 1 minus 1? Square root of 9. What is the distance between those two? And that's how I use the distance formula. Subtract your x's, square them. Subtract your y's, square them, add them together, and take the square root. Find the distance between these. They've given us negative numbers for a point because when you square it, it's going to automatically become positive. So let's look at what happens here. Subtract my x's. We have 6 minus a negative 2. 6 minus a negative 2. Plus, subtract my y's. Negative 5 minus a negative 9. And square it. All right, remember when you're subtracting a negative, that is adding. So what is 6 minus a negative 2? It is 8 squared. 5 minus a negative 9. 4 squared. If I had gone the opposite direction, let's say I had done negative 2 minus 6, I would have negative 8 squared. If I had done negative 9 minus a negative 5, I would have negative 4 squared. It will still work out the same no matter which direction you subtract, because when you square a negative, it becomes positive. So 8 squared is 64. 4 squared is 16. What am I going to get there? Square root of what? Yes, and so on this one, it also does not have a perfect root, but that is not in simplest form, all right? So just like every other time, when you do these, it's like giving me a fraction that's not reduced, okay? You don't want to leave it like this. You always want to check and see if you can simplify it. So you are going to take this and you are going to use your factor tree and you are going to simplify it. All right. If it pairs up, it comes out. If it doesn't, it stays in. So I have 2 comes out, another 2 comes out, and then I have a 5 that stays in. So my final answer here is going to be 4 square root of 5. So anytime you don't have a perfect root, you want to check to see if you can reduce it. Just like anytime you have a fraction, you want to see if you can reduce it. All right, so let's try distance. Try these two. All right, so for the first one, you are going to subtract your x's. 3 minus 0 squared. 4 minus 0 squared. Which gives you 3 squared plus 4 squared. Which gives you 9 plus 16 square root of 25, which is 5. All right. And even if you've done the other way, if you did 0 minus 3, negative 3 when you square it is also a positive 9. Negative 4 when you square it is also a positive 16. For this one, you're going to subtract your x's. 1 minus 4 squared. Subtract your y's. 8 minus a negative 1 squared. 1 minus 4 is negative 3. 8 minus a negative 1 is 9. All right, so we get square root of 9 plus 81, which is the square root of 90. Now 90 is not a perfect root, but we can factor it. The 3 will come out, the 2 and the 5 will stay in, which gives us 3 square root of 10. So finding the middle of a line when it's just a horizontal line or a vertical line is easy. You just cut it in half, right? If I want the midpoint from 0 to 10, it's going to be 5 because 10 divided by 2 is 5, right? Well, for a diagonal line, it's not quite as simple. you have two things to consider, the x movement and the y movement. But you just cut those in half. So if I have my xy and my xy, I am going to add those two together and cut that in half, average your x's, add your y's, cut that in half, average your y's, and that will be the new xy value of your line. And so that is the midpoint formula. The midpoint formula is to find the middle of a line, the point that is the direct middle of a line. You average your x's, add your two x's up, divide by 2. Average your y's, add the 2 up, divide by 2. So your answer will be an xy answer, okay? So for a distance formula, you're going to have one answer, just one number, whether it's a radical, whether it's a whole number, whatever. For midpoint, you're going to have two numbers, an x and a y as a coordinate point, okay? But it's really simple to use. Find the midpoint of the segment, and it gives you the endpoints. And you can have positives and negatives here, unlike distance formula, all right? So I'm going to add my x's. -3 plus 5, that is my x's, and divided by 2, that will be my x value. My y is 1 plus 4, divided by 2, that will be my y value. -3 plus 5 gives me a 2, so I have 2 over 2. 1 plus 4 gives me a 5, 5 over 2. You do need to reduce fractions, but I actually allow you to leave it as a improper fraction. If you are graphing it, you may then want to leave it as a mixed number because it's easier to graph 2.5 than 5 halves. But I will take either one of these as your answer. As long as your fractions are reduced, I'll take it as an improper fraction or a mixed number. But midpoint's very easy. All right, so try one midpoint or two midpoints.